Hey everyone, in this video we're going to build a dialogue system in Unity with a focus on 3 key features that are critical for RPG-style games. First, we'll let the player make choices that can branch the dialogue in different directions. Second, we'll add the ability to trigger things in the game directly from the dialogue, like starting or finishing a quest. And third, we'll show different dialogue depending on the state of anything in our game, for example, having an NPC say something different depending on the progress state of any given quest. And while this might sound a bit overwhelming to create, we're going to use something called Ink to write our dialogue, which integrates very nicely with Unity and significantly simplifies the complexity of building out a system like this. And if you've never heard of Ink before, don't worry at all about that. This video will be covering everything from how to write Ink dialogue to integrating that dialogue into a Unity project. And speaking of which, for this video we will be starting with a project that already has a quest management system in place from some previous tutorial videos. However, this video is intended to be standalone in that you don't have to have seen any of those previous videos to understand the dialogue system that we'll be building in this one. That said, there will be some implementation specific to the project that we're starting with, but I'll be doing my best to provide all of the relevant context so that you can understand what we're doing and work it into your own project as appropriate. And as always, everything that we're going to do can be found on GitHub, which will be linked in the description of this video. But one last thing before we get started, and that is I actually already have an entire series on building a dialogue system in Unity using Ink, and so I just want to take a minute to explain the difference between that series and this video. So there's a lot I could say here, but it really boils down to a couple of things. First, I've learned a lot since creating that series a while back, and as a result, this video aims to present a dialogue system that's, in my opinion, more robust and accounts for a lot of the pitfalls I saw people fall into in that previous series. However, that does come at the cost of using some higher level design patterns like event-driven architecture, which beginners to programming tend to find a bit more confusing. And second, the features for the dialogue system that we'll be implementing in this video revolve around facilitating quests, whereas the previous series contains a bunch of general features like portraits, typing text, and more. However, with that said, if you follow this video, it should be pretty easy to follow the specific video from that previous series for any additional features that you might want to implement. So I hope that all makes sense, but to put it simply, the previous series is more beginner-friendly and covers more features, whereas in this video we'll build a more robust system, and for any features that we don't cover, those specific videos from that other series can be followed after this video. And if you're still not sure which one you should watch, I'd recommend continuing on with this video and only worry about that previous series if you feel like this video is too fast-paced, or you feel like you'd benefit from a more beginner-focused approach. With that out of the way, let's get into how all of this is going to work. And just to give a quick disclaimer, this is going to be a lot of information all at once, and the main goal here is to prep you in thinking about what we'll be building and give you some context on why we're building the system the way we are. But if you don't quite follow everything that we talk about, don't worry about that too much, because we'll be reinforcing all of the following design when we go to implement the system itself later on in this video. But back to how this is going to work, our 3 key features, or put differently, our requirements are that 1, we're able to branch the dialogue using choices, 2, we're able to trigger things in the game from the dialogue, and 3, we're able to show different dialogue depending on what's happening in the game. Like I mentioned earlier, we'll be using something called Ink to help us accomplish this, which is a narrative scripting language for video games that integrates nicely with Unity as well as other popular game engines. How Ink works is that we'll write all of our dialogue, including dialogue logic like choices, conditional dialogue, and more, in separate files called Ink files using Ink's custom syntax. Which, don't let that scare you off, it's really easy to learn. Ink even comes with its own custom editor called Inky that helps a lot with writing the dialogue, and of course we'll be covering the basics of Ink syntax to get you started as part of this video. Then with our dialogue written, we can use the Ink integration plugin to turn that into a story object that our C# code can work with. And just to note, Ink allows one file to reference other files, so we can have as many Ink files as we want for organizational purposes, but for how we're going to go about building the system in this video, one of those Ink files will be considered a main Ink file, referencing any others from there, such that we only ever have one story object on the C# side. And how the story object works is really simple. We can do things to it, like set variables, jump to specific points in the dialogue, bind functions, and much more, some of which we'll dig into later on in this video, but most importantly, we'll use it to move through our dialogue one line at a time. That is, until we reach a line with choices that branches the dialogue in different directions, in which case we just need to tell the story which choice index to go down, which starts at 0 for the first choice and then increments accordingly for each choice after that. We'll get into more specifics later in this video, but I wanted to touch on the story object now since it's at the heart of the dialogue system that we'll be building. Speaking of which, there are a lot of ways we could design a dialogue system using Ink and Unity, but what we're going to do is create a C# class called Dialogue Manager, which will have the responsibility of managing that story object. For this project, almost everything is following an event-driven architecture, so we'll stick with that design pattern and create an enter-dialogue event that can be sent out from anywhere in our game. And of course, the Dialogue Manager will listen for that event and then start dialogue when it receives it. But for an RPG-style game with quests, we may talk to a bunch of NPCs in any particular order, so our dialogue isn't exactly going to be linear. As such, we'll need a way to jump to a specific section of the dialogue, which luckily for us, we can do in a very clean way using something called knots in Ink, which we'll get into more later. But essentially, we can separate out our dialogue using string IDs, also known as knots, and then jump straight to the start of a knot whenever we start dialogue. So we'll pass along the knot name as part of the enter dialogue event, so that way we know where in our story to start the dialogue from. Next, we'll need a way to display the dialogue to the player, and for that we're going to create a separate script called Dialogue Panel UI. This script will be attached to the user interface that will display the dialogue and any choices to the player, and at the start of the game it'll hide the UI by setting it inactive in the scene hierarchy. Then whenever we start dialogue, we'll have the Dialogue Manager send out a Dialogue Started event to inform other components that dialogue has been started, like the Dialogue Panel script, which will show the UI upon receiving that event by setting it to be active. Then, as mentioned earlier, the story object will give us a single line of dialogue at a time, including any choices that go with that line. So whenever we want to display a line, we'll send out an event called Display Dialogue from the Dialogue Manager that passes along the dialogue line as well as any choices. Then the dialogue panel will listen for and receive that event, setting the display accordingly to that information. If there aren't any choices, we can just continue to the next line in the story when the player presses the submit button. However, if we do have choices, we'll need a way for our dialogue manager to be aware of which choice the player chooses in the UI. So we'll do this by sending the selected choice index in our UI back to the dialogue manager using another event called update choice index. And with that, when the player presses the submit button with a choice selected in the UI, our dialogue manager will be aware of the choice index that is, and can then set it on the story and continue down that choice path for the next line of dialogue. And that process simply repeats until eventually the story will run out of dialogue lines, indicating we've reached the end, and at that point we'll send out a dialogue finished event from the dialogue manager to tell other components in our system that we've finished dialogue, like the dialogue panel script for example, which will hide the UI by setting it to be inactive. And that pretty much covers the foundation of this dialogue system and how choices are going to work, but our next requirement is that we want to be able to trigger things within our game directly from the dialogue. This actually ends up being pretty easy since we're using Ink. All we have to do is bind a C# function to the Ink story, and then we can call that C# function directly from the Ink dialog file. And with that, our bound C# function can do whatever we want it to in the game, which for this video we'll be using this technique to start, advance, and finish quests, and we'll get more into the specific implementation of that later on in this video. And so then for our last requirement, we'll want to show different dialogue depending on what's happening in the game, which we're going to refer to as conditional dialogue. Ink also simplifies this quite a bit for us because in Ink dialogue we can declare and use variables. That means that when writing our dialogue, we can use those variables to show different dialogue under different circumstances. Then on the C# side, we'll keep track of the current value of all of those variables depending on what's happening in the game. More specifically, we'll use an event called update Ink dialogue variable that can be sent out from any script in the project, and as the name suggests, the dialogue manager will listen for those events and update the C# dictionary according to the variable name and updated value. And so as long as we keep that C# dictionary up to date with what's happening in the game, it's as easy as setting those current values on our story object anytime we enter dialogue. And with that, our story object will keep up to date with what's happening in our game, which later in this video we'll be implementing so that our dialogue is aware of the progress state for any given quest. And that's how this is all going to work. So next, before we get into building out the dialogue system in that Unity project, we're going to take a quick look at how to write dialogue using Ink. We're only going to cover the foundational and relevant bits for this video, but I do have a longer video out there if you wanted to get a more in-depth but also fairly quick overview of writing Ink dialogue. So we'll start by installing the Inky editor from Inkle's website, which is the program we'll be using to write our dialogue dialogue. And once installed, we can open it up, and if the text is a bit small, you can use the Ctrl+ shortcut to make everything a bit bigger, and likewise Ctrl- to make everything a bit smaller. On the left side, we'll see some dialogue written using the Ink syntax, and on the right side, we can actually interact with that dialogue to ensure it's working like we'd expect it to. We can also use these two buttons on the top right to go back a single step in the dialogue, or go all the way back to the beginning of it. For right now, let's start from scratch and delete everything on the left, and then we'll type some plain text here which represents a single line of dialogue, and if we hit enter, we'll be typing a second line of dialogue which can be seen over here on the right. And in Ink syntax, it doesn't matter if there's extra space between these lines because Ink will only display the lines with content on them. And we can also add comments if we'd like, just like you would in C# by adding either two forward slashes at the beginning of a line or using this block comment syntax to comment out a big chunk all at once. One of the most useful features for learning Ink is this Ink dropdown, which if we click something, for example a knot, it'll put an example of that straight into our dialogue. This Ink dropdown contains most of the fundamentals to using Ink, but it's not all inclusive, and it's best used in combination with Ink's official documentation. Anyways, a knot represents a section of our dialogue that we can jump to, and it's declared by using these three equal signs on both sides of the knot's name. But you probably already noticed that nothing is showing up on the right side, and that's because we need to jump to it somehow. We can do this directly from our C# code, which we'll be doing later in this video, or we can do this from anywhere in the Ink dialog file itself using something called a divert. So if I go to the top of the file and then go to Ink, basic structure, divert, we'll see that a divert looks like this, where we have an arrow followed by the knot name that we want to jump to. So we'll change that knot name to match our knot, and then now we'll see the content show up on the right side as expected. And as you might have already guessed, this end part down here is also a divert, but this is one that's built in the Ink and indicates that the dialogue is completely finished. When using knots, we either need to use a done or end divert to indicate the end of our dialogue, otherwise we'll end up with an error that we ran out of content. And there is a small difference between end and done, as done indicates that we're finishing a flow within the dialogue, while end indicates that we're finishing all of the dialogue. But don't worry too much about that, because for everything that we're going to do in this video, we can use either done or end interchangeably. Next, let's write out a line of plain text, and then on the next line, go to Ink, Choices, Basic Choice, which shows us that we can do a basic choice by starting a line of text with a star symbol. So we'll make a choice for yes and a choice for no, and then we can add some text below for the responses to each choice. And just to note, the indentation I'm doing here is completely optional. I'm just doing it because I think it makes the dialogue a bit more readable. Then over on the right, we can click through our dialogue and see the choices play out. And one thing we'll notice is that the choice prints out as its own line of dialogue as well, which might be something you want, but if you don't want that behavior, you can just put the choice in brackets and then it'll jump straight to the response text and not print out the choice at all. And you can also do some fancier things with this, like only print out parts or variations of the choice depending on where you put the brackets, but we're not going to get into any of that in this video. Next, let's turn this into a knot called music question, add a divert to the start of the file to call it, and then we'll also add end diverts to the end of each choice. And this works exactly how it did before, but let's say we wanted the player to be forced into saying yes before the dialogue ends. Instead of diverting to end for the no option, we'll divert back to the music question knot. Now, if we choose no, the dialogue jumps back to the top of the music question knot and repeats itself. But you might notice that we only have a yes option this time, and that's because the type of choice that we're using is a basic choice. A basic choice indicated with a star is non-repeating and as such can only be chosen once for a single instance of dialogue. We can change that to a sticky choice by changing the star to a plus sign, and now no matter how many times we hit that choice, we can always select no as an option. And so that covers most of the basics. Now let's try something a bit more practical for what we'll be doing later in this video. Let's say in our role-playing game that we have an NPC that won't talk to you unless you've finished a specific quest. How we'll set this up is that we'll create a knot for the NPC's dialogue and then go to Ink, multi-line logic, and condition. We can think of this like an if statement where if this variable is true, we'll do this dialogue, otherwise we'll do the dialogue in the else statement. We'll change this to use a variable called quest completed, but we'll need to declare this somewhere as well. So at the very top of the file, we'll go to Ink, variables, global variable to declare a global variable, and we'll call it quest completed and set it to false. And then just to see this work so far, we'll add a divert to jump to the NPC knot, and we'll see that the text is ... because we haven't completed the quest yet, but if we change that to true, we'll get the dialogue in the top of that conditional block instead. Or alternatively, we can change it at any point within our dialogue with this syntax here using the tilde symbol. And with that, we can create whatever conditional logic we want based on the current state of our game, which opens up a lot of possibilities for writing dialogue. You might have also noticed that we can have temporary variables as well, and the main difference here here is the scope at which we're declaring it, much like if a variable is declared at the top of a script in C# versus inside of a method. But that's not something we need to worry about for this video because our use case is to sync these variables with our Unity project. And for that, they need to be global, and so we won't be doing anything with temporary variables in this video. And one last important thing to mention about variables, and that is in Ink, they are dynamically typed, meaning that Ink is smart enough to figure out if this is a Boolean, number, or a string, so you don't need to declare the type like you would a variable in C# code. And with that, I believe that's pretty much everything you need to know about Ink syntax for this tutorial and to get started writing your own dialogue. But again, I do have a longer, more in-depth video that covers more of the stuff that Ink can do, if that's of interest to you either now or later, but don't feel like you need to be an expert or anything because we won't be doing anything too complicated in this video. And next, I want to cover the relevant parts of the project that we'll be starting with, just in case you haven't followed those previous tutorials. The project is a really simple top-down game where the player can run around in this small scene and collect coins to increase their coin count or collect gems to level up, and as mentioned before, there's already a quest management system in place that was created in a previous video where we define static information about each quest in scriptable objects, like its unique ID, requirements to start it, and so on. And then we keep track of dynamic data like the quest's current progress state in a quest object that's managed and kept up to date using another script called the Quest Manager. The entire project uses event-driven architecture where events are set up using this Game Events Manager script, which is a singleton that we can call from anywhere in the project to send or subscribe to events. And for this project, it's worth noting that the Game Events Manager has been put above the default time block in the script execution order, so that way we can subscribe to events in onEnable without having any race condition issues on startup. Then to facilitate movement through a quest state, we have some events set up that can be sent out from anywhere in the project, and the ones we'll be using in this video are Start Quest, Advance Quest, and Finish Quest, which all move the quest through the appropriate state for a given quest ID. And there's also a quest state change event that gets sent out anytime a quest state changes in the game, which we will use later in this video. And right now we're sending out these start and finish events from a quest point script, which can be attached to anything in the game to act as the start and or finish point for a quest, which later on in this video we'll modify the quest point script to start some dialogue instead of directly starting or finishing a quest. And the last thing I'll mention is that this project is using Unity's new input system in an event-driven way, and I've already got actions set up for all of the input that this project needs. So all we need to do for this project to work with player input is subscribe to an appropriate event for that button press. And that should be all of the important bits of the project that we're starting with, but if at any point you need more context, I realize the previous videos are quite long, so to save you some time, you can likely gather all of the context for the system and this project by watching through the project overview timestamp of the first video. Finally, let's get into the actual implementation of the dialogue system. And with that, the first thing we need to do is install the Ink integration for Unity plugin, which you can find by searching for it on Unity's asset store, and after you've added it to your assets, you can go to Window, Package Manager, and then select My Assets from this dropdown, and then click on Ink integration for Unity, and then Import. And I'm just going to leave everything checked and then click Import again, and then once finished, you should end up with this Ink folder in your project. Next, we're going to create our first Ink dialog file for this project, which to keep organized, we'll create a new folder under Assets called Ink Dialog, and in that folder, right-click, Create, and then Ink, and we'll call the file All Dialog. And then, as long as you have the Inky editor installed, we can double-click the file with the Ink icon to open it up. For now, just so we have something to start building out the dialogue system with, we'll create a knot called NPC, and then just put a couple of lines of text in that knot, and if you wanted to, you could divert to that knot as well so we can see the preview on the right side. But we don't need to do that because instead of jumping to this knot in the Ink file, we'll be jumping to it in our C# code in just a bit. Then remember to save the file and we'll jump back into Unity. So a couple of things to note before we continue on. First, if we look in the inspector with the Ink file selected, we can see its contents here, and there's even a way to play through it in the Unity editor. I'm not going to dig into that, but feel free to play around with it a bit yourself. Just remember that we removed that divert, so currently the story will look blank just as it does in the Inky editor unless we add that divert back. And second, you probably noticed that we have a couple of files here. The one that we just edited contains the Ink syntax, and that's the one that we'll always write in. And the other one is a compiled JSON string of the dialogue we just wrote, which is what will turn into a story object in our C# code later on. This JSON file should recompile automatically whenever the Ink file changes, but if you ever need to force a recompile, you can go to Assets, Recompile Ink to do so, or if you're ever experiencing some other odd issues with the Ink libraries, you can also rebuild those from this menu. So now that we have an Ink dialog file ready to go, we're going to set up the foundation for working with it. And to start off, we'll focus on how we're going to enter dialogue in this project. By our design earlier in this video, we'll first create an enter dialog event that sends along the not name that we want to jump to. In the scripts events folder of the project, we'll create a new C# script called dialog events and then double click it to open it up. And in here, we'll add a using statement for system and then define a new event action that takes in a string for the not name, like so. And more recently, I learned you can shorten this syntax by quite a bit by doing it like this instead, where this question mark is basically your null check instead of checking for null with an if statement. But that said, I'm going to use this longer syntax in this video simply because my other events follow that longer structure already, and I'd rather keep that syntax consistent across the project. And also, this script isn't going to be attached anywhere in the scene, but instead we'll be creating it from the game events manager, and as such, we want to remove mono behavior from up here. Then in the game events manager script, we'll add a dialog events object so that all of our dialog events we create can be accessed from our other scripts. And now that we have that event set up, we'll want to send it out from somewhere in our project to trigger dialog. For this project, we have this quest point script which acts as the start and or finish point for any quest that's triggered when the player presses the submit button within range of this collider. And so we're going to modify that script to optionally trigger dialog instead, but this may differ for your own project. So in the quest point script, we're going to do this by adding a string variable for the not name that we should enter, and then down here when the submit button is pressed, we'll check if that not name is empty, and as long as it isn't, we'll send out that enter dialog event, passing that not name along. But if the not name is empty, we'll just do what we were doing previously and start or finish the quest depending on the quest point's configuration and the state of the quest. Then in the inspector, we'll modify this quest point to jump to the NPC not in our dialog, and that should be all good to go. Next, we're going to create the dialog manager script that's going to listen for that event and then start dialog using our Ink file. So in the scripts folder of the project, we'll create a new folder called dialog, and then in there we'll create a new C# script called dialog manager and then double click it to open it up. First, we'll create a method called enter dialog that takes in a not name, and then we'll subscribe that method to the enter dialog event in on enable, and as a best practice, we'll unsubscribe from that event in on disable. Then it'll be useful for us to know if dialog is currently playing internally for this class, and so we'll create a private boolean called dialog playing and start it out as false. Then whenever we enter dialog, we'll set that to true. Now let's consider the case where the player is spamming the submit button and we get a bunch of enter dialog events at once. We wouldn't want to enter dialog more than a single time, so at the top of this method we'll add a conditional check for if dialog is playing, and if it is, we'll just return right away so we only ever enter dialog once. And just to see this working so far, we'll also add a debug.log statement here to print out the not name that gets passed in. Then back in Unity, we'll create a new game object in the scene called dialog manager, and for this project that'll be under the manager's game object, and then we'll attach the dialog manager script to that so that it exists in the scene. With all of that, we'll go into play mode to test things out so far. And what we should see is that when we're within range of that quest point trigger and we hit the submit button, we enter dialog for the not name defined by the quest point, as can be seen with our logging. And also, if we press the submit button over and over again, we won't see any other logging statements, which shows that we're also only entering dialog a single time, just like we wanted. Next, we'll do something a bit more interesting and actually print out the lines from our Ink dialog file. Back in the dialog manager script, we'll add a using statement for ink.runtime, and then we'll create a private text asset variable called ink.json, which will be our compiled Ink file, and we'll also create a private story object called story. Then in the awake lifecycle method, we'll set that story to a new story and simply pass in the ink.json file .text to create it. Then when we enter dialog, I'm going to remove that logging from before, and we'll check if the not name passed in is an empty string, just as a bit of a defensive check, and if it is, we'll log a warning to let ourselves know. But if it isn't an empty string, we'll call story.choosePathString with that not name to jump to that point in the dialog. And next, we'll actually want to display the first line of that dialog, in which we'll call another method called continue or exit story, which we'll create right below that. And in here, we'll check if the story can continue, which will be true if we can access the next line of dialog, but will be false if we've hit a choice path or if the dialog has hit the end. But for now, we'll simply get the current line of dialog and print it out to the console when we can continue, and then just exit dialog when we can't. And below that, we'll create the exit dialog method, which will be pretty simple to start off. We'll print to the console that we're exiting just so we can see that later, and then we'll also set the dialog playing variable to false so that we can enter dialog again. And one last thing with how this system is going to work, we'll also want to reset the story state here, so that way whenever we talk to an NPC, the story isn't carrying over any state from a previous interaction. So with that, we'll be continuing the story once right when we enter dialog to show the first line, but we'll want to call this method again to continue to the next line of dialog every time we press the submit button. With how input in this project works, we just need to subscribe a method to the submit pressed event in onEnable enable, and of course unsubscribe in on disable. And then in that submit pressed method, which will be called anytime that button is pressed, we'll make sure that if dialog isn't plain, we'll ignore that button press by returning right away. But if dialog is plain, we'll continue to the next line or exit dialog by calling that method from here. Then back in Unity, we'll make sure to drag the compiled ink.json file into that slot on the dialog manager, and then we can hit play to try this out. And if we go talk to that NPC, we'll see that those two lines of dialogue in our ink file both print out, and after that we get the logging that we exited dialog as well. However, you might notice that the dialog immediately starts over from that first line after we exit, and if we continue through it again, it'll keep looping indefinitely through those two lines. What's happening here is that the submit pressed event is being handled in two different places at the same time. First in the quest point script to fire off the event, and second in the dialog manager script to continue or exit the dialog. So we end up with a race condition where if the dialog manager submit pressed method triggers first, it exits dialog right before the method in the quest point script fires off to enter dialog, putting us in a loop, which is a really common pitfall people run into as they add more systems to their game that use the same buttons. You may or may not see this behavior yourself, but even if you don't, you'll still want to fix this. Since it's a race condition, it may pop up later on when the environment changes, like in a production build, which we definitely don't want happening. With that, there are a bunch of different ways we could go about fixing this. A more quick and dirty way might be to make the exit dialog mode method a coroutine, and then wait until the end of the frame before exiting dialog, so that way the button press and dialog playing being set to false happen on different frames and the race condition no longer exists, which should work just fine for a lot of games. And if we make that change, we'll see that the issue should be fixed where once dialog exits, it doesn't start playing again until we hit the submit button again. But with this approach, if you're using the same button press for a lot of different actions in the game, not just two like we're dealing with here, things can get complicated really quickly, and you might end up having to do this trick in multiple places, potentially waiting different amounts of time to avoid race conditions. So instead, a different approach we could take is adding the idea of context to our input events. That means for button presses that can affect multiple things at once, we'll pass along an enum value for the context, for example default or dialog. Then we can change the context appropriately when we enter or exit dialog, and then any other script that takes in that input event will have the appropriate context, at which point each script can use that context to determine if they should handle that event or not. So I'm going to remove that quick and dirty approach by converting these things back in the dialog manager. And then in the scripts input folder, we'll create a new C# script called input event context and then double click it to open it up. And we're going to make this an enum with all of the different input states that we'd want to manage for our game, which for this project, we're going to keep it simple and just do a default state and a dialog state. And next, while we can implement this in a couple of different places for this project, we're going to do it directly in the input events class, which is just like the dialog events class we created earlier, but this one contains our input related events for the project. So at the top, we'll create an input event context variable that's only publicly gettable, and then set that to default to start out. Then we'll create a public method to change that context called change input event context. Then we'll add that to our submit pressed action by modifying the action and injecting that context when the action is called. And next, anywhere that submit pressed action is being received, we'll need to add that context. So first in the quest point script, in which case we'll choose to return right away if the context is anything other than default. And second, in the dialog manager script, in which case we'll choose to return right away if the context is anything other than the dialog context, replacing that dialog plain variable check that we had previously. And finally, we need to set that input event context to dialog when we enter dialog, and of course set it back to default when we exit dialog. And just like that, if we go back into play mode, we'll see that the issue has been fixed and dialog no longer loops when we try to exit. And if you followed the previous videos in this series and want to take this a step further and prevent the player from toggling the quest log during dialog as well, you could also pass that context through the quest log toggle pressed event and handle it accordingly. You could even add a quest log state to this enum to help manage it, but we're not going to do that in this video. And one last thing we probably want to do before we move on is freeze the player in place while the dialog is playing, which in this project there's already enable and disable player movement events set up that we can send out from anywhere to freeze or unfreeze the player's movement. So I'm just going to use those, but of course you'll need to handle freezing the player in whatever way is appropriate it for your own game. With that, when we enter dialogue, we can send off the disable movement event, and when we exit dialogue, we'll send off the enable movement event. And now back in play mode, when we enter dialogue, we won't be able to move the player anymore until dialogue ends, in which case movement is re-enabled and we can move again. Next, we'll create a UI to display this dialogue in the game instead of just displaying it in the console. And we'll start by creating those events that we're going to use to communicate with it from the dialogue manager. Back in the dialogue events script, we'll create a new event action called onDialogueStarted, another one called onDialogueFinished, and another called onDisplayDialogue that takes in a string for the dialogue line to be displayed. Then back in the dialogue manager script, we'll send out the dialogue started event whenever we enter dialogue, and likewise the dialogue finished event whenever we exit dialogue. And then finally, we'll replace this logging statement with the display dialogue event passing along that dialogue line. And I'm also going to remove the debug.log statement in the exit dialogue method, but you can keep that if you want to. Next, back in Unity, we're going to create a really simple dialogue panel user interface that's going to display the dialogue to the player. So under the UI canvas in the scene hierarchy, we'll create an empty game object called dialogue panel UI, and then under that, we'll create another empty game object called content parent. Then under that, we'll go to UI image to create an image and call that backing panel, and we'll resize that for how big we want the dialog panel to be and position it at the bottom of the screen like so. And I'm also just going to round out these values here with an X position of 0 so that it's completely centered, a Y position of -250, a width of 1000, and a height of 200. And then I'm also going to change the color to be black with a little bit of opacity. Next, we'll create the text under the content parent by going to UI, text, text mesh pro, call it dialogue text, and we'll position that accordingly in our panel. Then we'll want to drag out this yellow boundary to define the margins for when the text should wrap, which in our case will fill up pretty much the entire box. And just like with the panel, I'm going to round out these values in the inspector. So for me, that's an X position of -375 and a Y of -200. And just to make sure the text is wrapping like we'd want it to, we'll make the placeholder text longer. Then I'm going to keep the font size at 36, and for the margins under extra settings, I'll round off the right margin to -750 and the bottom margin to -80. And last, we'll also add a continue icon under the content parent by going to UI, image, calling that game object continue icon. And then I already have a really simple image that I made that we're going to use under the art icons folder of this project that I'll drag in, and we'll change the size to be 32 by 32 and position it at the bottom of the dialog panel, rounding that value out to a Y of -320. And that does it for the first cut of the dialog panel UI. We'll come back to this to add choices later on, and for now we can also disable the content parent game object. Next, let's make this functional by subscribing to those events that we created earlier. In the scripts UI folder of the project, we'll create a new C# script called dialog panel UI and then double click it to open it up. Then we'll start by declaring the components that we'll be modifying, those being the content parent game object and the dialog text text mesh pro U GUI object, which for that, make sure you're using TM Pro at the top to be able to reference that. Then we'll create an awake method in which when the game first starts up, we'll want to ensure the content parent is inactive in the scene hierarchy. Then we'll create a method for when dialogue is started, and in there we'll simply set the content parent to be active, and likewise a method for when the dialogue has been finished where we'll set the dialogue panel to be inactive again. Then we'll create another method called display dialogue that takes in a string for the dialogue line, and in there we'll just set the text mesh pro text to be equal to that. And one last thing, just as a best practice, we'll create a reset panel method which we can use to reset the panel to an initial state, which right now that just means our text will be set to an empty string, and we'll call that reset method whenever we finish dialogue so nothing carries over, as well as in the awake method so that way we're always starting from that initial state. And finally, all we have to do is hook up these methods to our events. So we'll create an onEnable method to subscribe to the dialogue started, dialogue finished, and display dialogue events, and likewise we'll unsubscribe from those events in onDisable. Then back in Unity, we just need to attach that script to the dialogue panel UI game object in the scene hierarchy by dragging it on, and then drag in the appropriate components to these slots. Then we can hit play to see if this is working so far. And if we go over to this NPC to start dialogue, the panel pops up and we're able to continue through our dialogue until it ends, just as expected. Next, we'll make some modifications to this to support choices. First, we'll need to include some choices in our Ink dialogue file. And so let's start changing this dialogue according to the actual quest in the game. In this project, this NPC is the starting point for a quest where the player has to collect 5 coins, and this NPC is the finish point for that quest. So let's write some dialogue that makes sense for that use case. Back in our Ink dialog file, we'll delete what we currently have here and then create a new knot called collect coins start. And just so we can see a preview of it over here on the right, we'll also divert to it at the top. Then we'll have the NPC ask if we can collect 5 coins and bring them to his friend, and we'll give the player 2 choices, yes and no, and we'll have the NPC respond appropriately to each choice, like so. And finally, we need to make sure each branching choice comes to an end, which we could divert to end for each of those choices, or we can use something called a gather, which is just done by using the dash symbol, which in Ink brings together all of the previous choice paths to this single point. And then from there, we'll divert to end the dialogue. Remember to save this file, and then we'll hop back into Unity to change the knot name for that quest point to match the new knot in our Ink file called collect coins start. And then let's go into play mode to see what currently happens. We'll see that when we talk to the NPC, the first line of dialogue is displayed, but when we hit continue, the dialogue just closes. That's because we hit a choice path, in which case this conditional check in our dialogue manager comes up as false, and as such we exit the dialogue. So for choices, we'll need to handle that case here by choosing a choice path to go down before we try to continue the story. And how we're going to do this is by adding buttons to our dialogue panel for each choice, which when selected will fire off an event to inform the dialogue manager of the selected choice index. Then when we try to continue the story and there are choices, instead of exiting dialogue, we'll continue down the currently selected choice path instead. So we'll start by creating those choice buttons in the UI that'll send off that event. So first, we'll need to add that event to the dialogue events class. We'll call it update choice index, and it'll pass along an integer for the choice index. And then next, we'll create the script that will send off this event. So in the scripts UI folder of the project, we'll create a new C# script called dialogue choice button, and then double click it to open it up. And in here, we'll add a few using statements to the top for UnityEngine.EventSystems, UnityEngine.UI, and TM-Pro. Then we'll start by defining the components we'll want to be able to access, those being the button, which we'll call button, and the TextMesh Pro object, which we'll call choice text. We'll want to be able to set the display text according to the choices in our Ink dialog, so we'll create a public method to set the text and do so in there. And we'll also want to be able to tell this button which choice index it is, so we'll create a private int called choiceIndex and initialize it as -1, and then create another public method called setChoiceIndex where we can set that accordingly. It'll also be useful later on to select the button externally, so we'll add another public method to do that. And finally, we'll want to send out that update choice index event whenever this button gets selected. And we can do that by implementing the iSelectHandler interface, which gives us this onSelect method that will fire off whenever this button is selected by Unity's event system. From there, all we need to do is send off the update choice index event, passing along the choice index for this choice. Then back in Unity, under the dialog panel UI object we created earlier, we'll enable the content parent so that way we can see everything. Then we'll create a new empty game object called choices, and under that we'll go to UI, button, TextMesh Pro to create a button which we'll call dialog choice button. Then we'll position this directly above the dialog panel and resize it to be longer, rounding out those values to a position of x = 0 and y = -125, and a width of 800 and a height of 30. Then we'll make the text be a white color and keep the alignment as centered. And then for the button itself, we'll make the normal color 0 opacity so there's no backing to it, and the selected and pressed colors a solid black with just a little bit of opacity. And real quick, when testing this later in the video, there was a strange blip in the color happening when changing choices, which seems to be because Unity does some kind of fade between these colors. So to fix that in this video, we can just change the normal color to be a solid black like the pressed and selected colors. And last, we'll attach the dialog choice button script that we created, which makes sure you're attaching this to the dialog choice button game object. And then we can drag in the appropriate components to these slots. And then to support multiple choices, we're going to make this a prefab by dragging it into the prefabs folder of the project. And one way we could support multiple choices is by instantiating the buttons at runtime, but we're going to take more of an object pooling approach instead, which means we'll support a maximum number of choice buttons in the UI, and then set them active or inactive in the scene hierarchy depending on how many choices we want to show. And so to do that, we'll just duplicate this button a few times so that we have 4 choices in total, or however many choices that you need to support, and then we'll position them accordingly, one on top of the other. And then just for clarity, I'm going to rename these from 0 to 3, where 0 is the choice closest to the dialog panel and 3 is the one that's furthest. list. And just to note, if you're following along to this video exactly, this naming will be a bit important later when we hook all of this up. Next, back in the dialogue events script, we have this display dialogue event that passes along the line of dialogue, but to support choices, we'll also need to pass along the choice information. So at the top, we'll add a using statement for ink.runtime, and for the display dialogue event, we'll pass along a list of choice objects in addition to the dialogue line whenever we use this event. Then in the dialogue manager, when we send out this event, we'll include the list of choices, if any, by calling story.currentChoices, and in the dialogue panel UI script, we'll change this to take in those choices as well, and don't forget to make sure you're using ink.runtime so that the choices get referenced correctly. And then with all of that set up, now we're ready to display those choices in our UI. At the top of the dialogue panel script, we'll create an array of dialogue choice button objects called choice buttons. Then in the display dialogue method, the first thing we want to do is a defensive check to make sure our choices UI has enough choices to handle the incoming amount of choices from our ink dialog file. And if it doesn't, we'll log an error to let ourselves know. And so next, the logic for displaying the choice information is going to be a bit complicated, so I want to explain what we're going to do. In the user interface, our choices are going from the bottom up. However, most games that do this will have the first choice be at the top still. So for example, if we have two choices, we want our choice buttons to get displayed like this, where the second button from the bottom is really our first choice index, and the first button from the bottom is our second choice index. From the ink story, we'll be getting our choices in a reverse order compared to how we want to display them. So to implement this, we need to loop over this information such that we're incrementing the choice index while decrementing the choice button. So back in the dialog panel UI script, we'll start by setting all of the choice buttons to be inactive in the scene. Then we'll define the choice button index we want to use as the amount of dialog choices we have, -1 to get the array index. And then we'll do a for loop with a variable called ink choice index, looping through all of the choices in our ink file and incrementing that index for each iteration. And likewise, at the bottom of this for loop, we'll decrement the choice button index. Then at the top, we'll use each index to get the corresponding choice information and choice button, set the button game object to be active, and then set the appropriate information for that button being the text and the ink choice index. And one last thing, if this is the first choice index, we'll also want to select that button, so that way we always start out with the first choice selected. But when testing this, I noticed it was only working that way about half of the time, and my best guess is that there's an issue with this handler method being called and setting the button active in the same frame. But that said, we can fix this pretty easily by sending out the update choice index event from the dialog panel script as well when we select the first choice button. And that does it for displaying the choices. The last thing we need to do is set everything up in the dialog manager to properly handle setting the choice index on our story object. So at the top, we'll add a private int called current choice index and start it as -1. Then we'll create a method called update choice index that takes in an integer and sets our current choice index to that. And of course, we'll subscribe that method to the update choice index event in onEnable and unsubscribe in onDisable. Then in the continue or exit story method, before we do anything else, if there are choices and one has been selected, we'll make the choice on our story object. And as a precaution, we'll also reset that current choice index variable so that we don't ever risk anything carrying over to the next choice. And as one more precaution, if we ever get to this else statement, but we have choices to be selected, we wouldn't want to exit dialog. So we'll modify this to be an else if and only exit dialog when we don't have any available choice paths to go down. And then back in Unity, we'll need to drag in all of our choice buttons to the dialog panel UI script. And like I mentioned earlier, the naming here was kind of important because how we have things implemented, we'll want dialog choice 0 to be on the top and 3 to be on the bottom. Last, I'm also going to disable the content parent for the dialog panel since we're done working in it for now. And from there, if we go into play mode, we can try this out and we'll see that our choices are functioning exactly how we would expect them to, where we go down the different choice paths in our ink file depending on the choice that we choose in the game. And that pretty much does it for choices, but there is one issue that pops up in some odd cases when using ink that I want to address and fix. Back in our ink file, if we remove the dialog for the no choice completely by commenting this out, and then go back into play mode and go through the dialog in our game, we'd expect the dialog to exit immediately after choosing no. But what actually happens is that we get a blank line of dialog resulting in this empty panel. There are a few different cases I've seen in ink where this might happen, but luckily it has a pretty easy fix. We just need to skip over blank lines when continuing the ink story. So back in the dialog manager at the very bottom, we'll create a private method to check if a line of of dialogue is blank or not, which we can do by checking if the trimmed line is equal to the empty string, or there is this other case that I've seen happen more rarely where the trimmed string may equal the new line character. And then in the continue or exit story method under the story.canContinue block, while the line is blank but the story still can continue, we'll move on to the next line, and then we'll do a conditional check after that to check if the line is blank but the story can't continue, in which case we'll exit dialogue immediately from here. Else, we'll send out the event to display the dialogue just like we were doing before. And with that change, we can play the game and we'll see that that issue no longer occurs, where when we select the no choice, the dialogue closes immediately and there's no blank panel. With that, we've got a good foundation set up for our dialogue system, and our first requirement, which was handling choices, is working like we want it to. The next step is going to be triggering things in our game directly from the dialogue using Ink external functions, and our use case is going to be starting the appropriate quest when we choose the yes option in our dialogue. So back in the Ink dialog file, the first thing we need to do is declare the functions that we want to bind to our C# code. So at the top, we can do this by saying external followed by the name of the function and whatever parameters, if any, that we want to pass to that function from the Ink file. And for this project, we'll create external functions for start quest, advance quest, and finish quest, all of which will take in a quest ID that corresponds to the quest that we want to perform that action on. Then to call this method, it's as simple as using the tilde symbol followed by the function name and whatever parameters we want to pass along. So in this case, the collect coins quest parameter corresponds to the ID of that quest in our game, as defined by the scriptable object for that quest. And I'm also going to uncomment this line here that we commented out earlier. And unfortunately, one of the downsides to using Ink external functions is that for some reason it seems to break the right side of the Inky editor when we call them in the Ink file. So if you really like that feature, you can consider using something like Ink tags instead of external functions, which I have another video on that uses Ink tags to implement portraits if you want to explore that route. But with that said, you can still set up the player in Unity to do this instead, but I'm not going to dig into that in this video. Anyways, remember to save your Ink file and then we can jump back into Unity. And next we'll create the C# method counterparts to those external functions. In the scripts dialog folder of the project, we'll create a new C# script called Ink external functions and then double click it to open it up. And in here, we're going to remove mono behavior as we're going to create and manage this from the dialog manager. And we'll also add a using statement for ink.runtime. Then we'll create different methods for each of our external functions, those being start quest, advance quest, and finish quest, all of which take in a string quest ID. And in those, we'll simply send off the corresponding quest events to start, advance, or finish the quest. Next, we need to bind these methods to our Ink story so that our dialog file is aware of these functions. To do so, we'll create a public method called bind and another public method called unbind, both of which take in the Ink story object. And in the bind method, we'll bind the external function to the story with the bind external function method, where this string needs to match the function name in our Ink file exactly, and then we'll pass along that quest ID parameter to the corresponding method. And in the unbind method, we'll unbind those functions by calling unbind external function on the story, like so. Then in the dialog manager class, we'll declare an Ink external functions variable up top, and in the awake lifecycle method, right after we create the story object, we'll create a new Ink external functions object, and then call the bind method to bind those functions. And likewise, as a best practice, in the onDestroy method, we'll call the unbind method to release those functions. And with that, back in Unity, we can enter play mode and start dialog, and if we choose yes to start the quest, we'll see that the quest actually starts, which shows that our external functions are properly hooked up and working as expected. And so that just leaves our third requirement, which is playing different dialogue depending on the state of the quest. As mentioned earlier, we're going to do this by maintaining some variables on the C# side and then syncing those variables with our Ink dialog file anytime we enter dialogue. And as an added bonus, we'll also sync this the other way in real time through the dialogue, where we can change the variable in the Ink file and it'll get updated in our dictionary on the C# side, which we won't really use in this video, but it's really easy to implement, and I can imagine a lot of people following this tutorial may eventually want that capability. So we'll start by modifying the Ink file to contain some conditional logic based on the state of the collect coins quest that we've been working with. For this project, our quest can be in any of these states. So for this example, we're going to make our variable a string that represents that state. But with that said, you can use the approach that we're going to implement with any type of variable for anything in your game. Anyways, if you wanted to do something that resembled an enum like this, but in Ink, you could use something called Ink lists. But doing so will make the Ink file more complicated, and in the interest of keeping things simple, we're just going to use strings that resemble the enum values. So we'll start by cleaning this up a bit by removing this divert and then making the collect coins quest a variable up top. Then we'll add a variable for the quest state, starting it out with a default value, which in this case will be requirements not met. And note that the variable name here is the quest ID exactly, including case sensitivity, followed by the word state, which will be important later with how we're going to implement this. And just to follow that convention, I did something similar for the quest ID as well. Then at the top of the collect coins start not, we'll use a switch statement, which works just like a switch statement in C# to do different paths of dialogue depending on that variable's value. And for the default case, we'll just divert to end, and for all other cases, we'll divert to other parts of the dialogue called stitches. Stitches are declared with one equal sign followed by the stitch name, and they indicate a subsection within the above knot. Within that knot, they can be diverted to using their name, like so, or they can also be diverted to from outside of the knot by using the knot name dot the stitch name. And so we'll copy and paste what we had previously into the can start state, and for the other ones, we'll just write some new dialogue that makes sense for each state. Then back in Unity, we're going to keep all of the dialog variable logic contained to its own script, just like we did with Ink external functions. So in the scripts dialog folder of the project, we'll create a new C# script called Ink dialog variables and then double click it to open it up. And at the top, we'll add a using statement for ink.runtime and then remove mono behavior. And then we'll start by declaring a private dictionary that maps a string variable name to the ink.runtime.object value. Then in a public constructor, we'll take in the story, initialize the dictionary, and then initialize all of the variables that we want to keep track of in a for each loop, where we'll get the variable's initial value by calling story.variablestate.getVariableName and passing in the name. And then we can add it to the dictionary like so. And for now, just so we can see this working clearly, we'll add a logging statement to see the variables that we're initializing. Next, we're going to create 3 public methods that'll represent the different ways that we can interact with our dialog variables. First, a method called sync variables and start listening that takes in the ink story. Second, a method called stop listening, and third, a method called update variable state that takes in the variable's name and new value. We'll also create a private helper method to set all of the variables from our C# dictionary to the story called sync variables to story, and in there we'll loop through each of the variables in that dictionary and then set them on the story object using story.variablestate.setGlobal, passing in the variable's name and value. Then for update variable state, we'll first check if the variable exists in our dictionary and then return if it doesn't, which we're doing as a defensive check to ensure we're only updating variables that were initialized by the ink file, and then we can update that value in the dictionary like so. And for now, we'll also add some logging here just so we can see this later when we try it out. Then when we sync and start listening, we just need to call that sync variables to story method, and then subscribe the variable changed event of our story to the update variable state method. And with that, if a variable changes during dialog in our ink file, our C# dictionary will stay up to date with those changes. And then of course, we'll unsubscribe from that event in the stop listening method. Then back in the dialog manager class, we'll bring this together by declaring a private ink dialog variables object at the top, and then initialize that in the awake method after we've created the story. And then in the enter dialog method, we'll sync variables and start listening there. And likewise in the exit dialog method, we'll stop listening. And last, we need to keep the variables in that dictionary up to date for our game, so in the dialog events class, we'll create a new event called update ink dialog variable that'll take in a string for the variable name and an ink.runtime.object for the variable value. And once more, back in the dialog manager, we'll subscribe to this event in onEnable and unsubscribe in onDisable. And in that subscribed method, we'll call ink dialog variables.update variable state, passing along the variable name and the updated value. Finally, we just need to use that event to keep our quest state variable up to date. In this project, we fire off a quest state change event anytime the quest state changes. So how we're going to do this is back in the dialog manager, we'll subscribe to that quest state change event in onEnable and unsubscribe in onDisable, and then in that subscribed method, we'll send out the update ink dialog variable event, where the name will be the ID plus the word state, since if you remember, we strategically named the variable in the ink file to correspond to this, and the value will be the quest state to a string wrapped in this string value object, which is just a more specific type that inherits from the ink.runtime object our dictionary is storing. And just to note, you might find this a bit redundant since we could just update the variable state directly when we receive the quest state change event, which in this case would remove the need for that update ink dialog variable event altogether. But the main reason I'm doing it this way is to illustrate how other scripts can update variable state in the future, since they may not always be from the dialog manager like this one is. And with all of that implemented, we can jump back into Unity and try this out. And just as expected, we can talk to that NPC and go through the quest, and the NPC has different dialogue depending on our quest progress. And if you wanted to troubleshoot something or just try to understand what's happening a bit better, remember that we added those logging statements so we can see a record of how our variables are being changed as we play through the quest. So keep those logs if you think that's useful, but for the rest of this video, I'm going to comment them out. And for this project in particular, since we developed a method of data persistence in a previous tutorial for the quest system, and our dialogue variables are getting updated according to that saved information thanks to how that quest state change event is set up, data persistence for our variable state is already being taken care of and we don't have to do anything else. That said, as you expand on this and potentially use variables that aren't managed by the quest system, you may want to save and load those other variables. While I'm not going to cover that in this video, I do want to mention that Ink has some built-in ways to save and load the story state as a JSON string, which I do cover briefly in another video if that's of interest to you. Just remember that we're resetting the state at the end of dialogue, so you'll need to account for that. And with how the system's set up, a better way might be to just save off the C# dictionary, since we're maintaining all of the variables there. But of course, the best solution to this depends on your own project and what you're trying to accomplish. Anyways, the final thing we'll do in this video is add some dialogue for this other NPC that acts as the finish point for that quest. As you can imagine though, if we start doing this in a single Ink file, things are going to be a bit cluttered, so we're going to split up this file into multiple where we have a main one and then one for each NPC. So back in Unity, we'll go to that all dialogue Ink file, and for clarity, we're going to rename this to main as it's going to represent the main dialogue file that references the other ones, and then we'll create two more Ink files, one called collect coins start NPC and another called collect coins finish NPC. Then we just need to double click the main dialogue file to reopen that up with the name change. And then if I click this menu up here, it'll expand this on the left where we'll see a list of all of the Ink files in this directory or any subdirectories. And so I'm going to take everything in the collect coins start knot, including all of these stitches, and paste it into the collect coins start NPC file. Next, to reference that in our main Ink file as if the content was still in that file, we can add an include statement followed by the file name, which, just to note, you can use relative pathing if you wanted to use directories as well to organize your Ink dialogue. And after we add that statement, you'll notice that it jumps from the unused file section over here to the main Ink file section to show it's being referenced. And so we'll add another include statement for the collect coins finish NPC file. Then, just to show something a bit different that you can do, we're going to finish the quest based on a conditional choice. So we'll create a knot called collect coins finish, where we'll have a short switch statement where when finished we'll divert to a finished stitch, otherwise we'll always divert to a default stitch. For the finished case, the NPC will just say thank you and we'll end there, but for the default case, the NPC will ask us what we want and we'll have a couple of choices. The first choice being nothing, in which case we'll just end right away, and the second choice being to give the NPC the coins that we've collected, in which case we'll finish the collect coins quest and the NPC will thank the player. However, we only want this choice to appear as an option if the quest is in the can finish state, which we can accomplish by adding a condition before the choice, like so. Finally, remember to save this and then we'll jump back into Unity. And since we changed the name of that main Ink file, we'll need to drag that back into the dialog manager in the scene hierarchy, which the one we want to drag in is the main compiled Ink JSON file, and we'll also need to update that second quest point to start dialogue using the collect coins finish knot, and with those changes we can hit play to try this out. And if we talk to that NPC before finishing the quest, we only get a single choice, but if we've collected the 5 coins and can now finish the quest, we'll get this additional choice to give those coins to the NPC. And of course, after we've finished the quest, we get dialogue indicating that instead. And that's it for this video. Thank you so much for watching, and huge props to you if you made it through this whole thing. This is one of the longest tutorial videos I've made to date, and it took me quite a while to get this out. My intention is that this wraps up the quest system tutorial series that I started a while back, and a big reason that this took so long is that I chose to double down and focus on completing my own passion project, which is a precision platformer video game called The Path of Ren, which I'm really excited to say it now has a free demo available on Steam, and I'm hoping for a full release sometime in Q2 of 2025. But anyways, if you thought this video was helpful, be sure to like it so more people see it, and if you want to see more from me, be sure to hit the subscribe button as well. With that said, thanks again for watching, and I hope this was helpful.